Hello students, in last video we introduced the thermodynamic terms. Okay, now let us discuss the thermodynamic term. What is what? That is what? Internal energy. There was a symbol for that one. We are denoting with the capital U. Okay, now let us define. How can we define the internal energy? So if you see the internal energy definition, what is given that internal energy is the total energy. Okay, it is a total energy contained by the thermodynamic system. Okay, already we discussed what a system means, what which is in under observation is called system. So in a system, whatever the energy is present, that total is called as a what? Internal energy. Means internally we have some energy, that sum of the all the energies called as a what? Internal energy. So it may be, if you see the what type of energy, it may be, you can tell chemical or electrical or mechanical. Rotational energy means what? Because of rotation of molecules, you are going to get the energy, that is called as a what? Rotational energy. Because of vibration, if you get the energy, called as a what? Vibration energy. Potential energy, nuclear energy, or any other type of energy. Okay. So internally, simple what? Internally, whatever the energy present in a system is called as a what? Internal energy. Here, absolute value of internal energy cannot be found. Means you are not going to, we cannot find the what only U. Mean absolute value we cannot find, but we care about only change in internal energy. Means we are going to find the delta U, but not the only U. Okay. So absolute value we cannot find, but we can find the change, that is delta U. Here, so let us see internal energy. What are the, we have the pHs. Okay. It depends on the quantity of substance. So it is in what? Extensive properties. In last video we discussed extensive properties, intensive properties. Extensive properties means what? Depends on the mass. So internal energy depends on the mass. Okay. So delta U is a heat evolved or absorbed at a constant volume. Okay. You can define another way. Delta U means what? It is the amount of heat absorbed or evolved at what? Constant volume. Important. At constant volume, whatever the heat is there, you are calling as a what? Delta U. If energy is evolved by the system, means system is losing the energy, then what is symbol? Delta U equal to minus negative. Okay, you have to show with the negative symbol. If energy is absorbed by the system, if system is taking the energy, then delta U equal to what? Positive. Okay, these symbols are important while doing the numericals also. Now, next if you see for isothermal process, already we discussed isothermal process. What means what? There is a change in temperature, delta T equal to 0. So in that process, internal energy change, delta U equal to also 0. You have to remember. Okay. So why? Because means temperature is directly proportional to internal energy. Okay. Now in isothermal process means what? Delta T 0 means delta T 0 means delta T also 0, delta U also 0. Okay. Now internal energy of the system which may change when, so if you want to change for a system, we have some internal energy. Okay, that you want to change mean you can change by doing what? Work is done on or by the system. Second, what? Heat passes into or out of the system. Third one is what? Matter enters or leave the system. Means you can change. For example, we have the internal energy for system. For example, this is my system. System means what? This is under my observation. Now you can do the change in system, changing in the internal energy by doing the work. Okay, by passing or some leaving the some heat, or so if matters enters or leave. Okay, whatever that may be, by doing any one of that, you can change the internal energy. Here I am taking the one system. Okay, system means under my observation. This total part is under my observation. For this, if I make this what system by making the some partition, so what happened? Internal energy going to become half. Okay, means it indicate what? Internal energy is a extensive property. Means it depends on the what? Mass. Here mass is become half, so internal energy also become half. So it indicate what? Internal energy is a what? Extensive property. Next. Now let us see the change in internal energy. Okay. Now we are going to change the internal energy first by work. Okay. Mean it constant value. Okay. Next internal energy change by heat. Okay. Constant value, that also. Internal energy change by heat and work together. That is also constant value. So you are going to measure the heat at what? At constant value. Okay. Constant value means indicate what? Internal energy. So in a three ways. Okay, in these three ways I am going to change the internal energy. Now let us see the first case. Okay, now so here what, let us take a adiabatic system. Okay, so here adiabatic system means what, there is a no exchange of heat, okay, between the system and surrounding. So this wall is called as what, adiabatic wall, and the system is called as what, adiabatic system. So in this case there is a no exchange of heat between the system and surrounding. That type of system is called as a adiabatic system, and this type of wall are boundary. Okay, it's about boundary na. Why? Because means it's going to separate system and surrounding. So this is imaginary boundary. Okay, this wall is called as a what, adiabatic wall. Now we are taking the word adiabatic system. Okay, now ways to change the internal energy. Now you are going to change the internal energy by churn it. Churn means, okay, generally you know where in Telugu lo gilakadam. Okay, churn it. Okay, means you are doing some mechanical work. Okay, so here we are doing what, changing internal energy by work. So churn it means you are doing some mechanical work. Okay, heat it with the immersion rod. Okay, if you heat with the immersion rod, that is what electrical energy you are going to provide. That also doing some work. Now chemical reaction. So you are going to what, chemical energy going to produce. So here in this three process you are going to do some work. Okay, in this work you are going to change the internal energy. Now if you see next, what is given there, the adiabatic work means I am simply writing as a WAD. Means why I am calling the adiabatic work means here I am taking the word adiabatic wall. So in this whatever the work I have done, that is called as the word adiabatic work. Okay, the adiabatic work required to bring about a change of state is equal to the difference between the value of U in one state and that in another state. That is delta U equal to 1 U2 minus U1 equal to W adiabatic. Means what here? Okay, here once you are doing some work, means there is a change in internal energy. Okay, so internal energy already we told, this is a state function. State function means what, depends on the initial state, final state. It does not depends on the path. Now here you are churning and heating with immersion rod, chemical rod. So by doing that what, there is a change in internal energy. Nothing but what, delta U. Okay, that whatever the change is there. So delta U means what, fine. Here you have to take the, it's a state function, means you have to take the final state minus initial state. So whatever the change in internal energy is there, that is equal to what, work for adiabatic process. So simply you can write delta U equal to W adiabatic. Okay, now here we have the sign convention for W adiabatic process. Okay, now so work is done on the system, so then you have to take the W equal to what, positive. Okay, work means at that time you have to take the symbol what, positive. Work is done on the system. Okay, if it is work is done by the system, if its work is done by the system, then you have to take the one W equal to minus negative symbol you have to take. Okay, this is negative symbol you have to take. Now what is the meaning of this one? Okay, work done by the system, work done on the system. In best example you take the piston. Okay, if piston is there, let us assume here we have the piston. Okay, this is we have the piston in there. If you hear this piston is there, once you here, if you pull down the piston, what happened? Okay, I am drawing neatly. So here we have the piston. Okay, okay, now in this piston, if you, what happened, if you pull this piston down, so what happened, this is called as work done on the system. Means you are using some pressure and doing some work on the system. This is why we call it system. Why? Because means it is under my observation. This is work done on the system. Now work done, so at that time you have to take the W equal to what, positive. Now work done by the system means what? By the system means, for example, if you remove this piston as easily without any pressure, what happen? It will be come up. Okay, so there is a expansion will take place, so it will be come up. So now here this is called W equal to symbol what you take, negative. This is what work done by the system. This is what work done on the system. So work done on the system means W positive, work done by the system means you have to take the word W symbol as a word negative. Okay, very very important by doing the numericals also. So work done by the system means you have to take the word negative. Simple. What we discuss here, if you made some pressure, so you are doing some work. So this is our system, and system you are doing some work. So work done on the system. So W what, positive. work done by the system. Simply you are leaving. So what happened? Because of pressure, this one, whatever the gas is there in this piston, it's going to be expand. So this is what work done by the system here. Okay, this is the work done on the system, this is by the system. So you have to take the W what? Negative. Next, units of work. Units of work, if you take if CGS units are Ergs and SI units are joules. Okay, why? Because means in the numericals we have to see this units also. Now here we have the conversion. 1 joule equal to 10 to the power of 7 x, or equal to what? 1 Newton meter. Okay. Next, units conversion, in that also you have to remember 1 liter atma equal to 101.3 joules, or you can write 1 liter bar equal to what? 100 joules. Okay, this is the conversions important while doing the numericals. Okay, this is the first case. Okay, what I did, I did the change in internal energy by doing the work. This is the first case. Now see the second case, internal energy change by heat. Okay, so all are at a constant volume only. Okay, we are keeping the what? Volume of the whatever you are taking the system is constant. Okay, this here also the volume of the system is constant. Here now we are going to change the internal energy by heat. Okay, now here taking the thermally conducting wall. Okay, means there is a exchange of energy. Okay, in this case what we done? There is no exchange of energy. Okay, so here in the second case we are going to change the internal energy, means definitely there should be passage of energy should be there. So we are taking the thermally conducting wall here. Okay, so we can also change the internal energy of a system by transfer of heat from the surrounding to the system, or vice versa, without expenditure of work. So here what happened? You are going to change the heat from system to surrounding, or surrounding to system. Okay, this is for system and remaining part is called as a surrounding. So there may be heat exchange between the system to surrounding or surrounding to system. So here this exchange of energy, which is a result of temperature difference, is called heat. So what is the exact definition of heat? Means, for example, you are heating this vessel. Okay, initial temperature T1 is there, final temperature T2 something. Okay, for example, this is we have the 100 degrees Celsius. If you going on heating, it reaches to 200 degrees Celsius. So there is a difference in temperature. That difference in temperature is called as a what? Heat. Okay, this definition of what? Heat. Now, thermally conducting walls instead of adiabatic system is used. Here what we have used the system in the system, we have the thermally conducting wall instead of adiabatic. Why? Because means we have to change the we have to change the internal energy by the what? Heat. Okay, let maintain constant volume and supply external heat. Now what we are telling? We have to take the constant value. I am going to apply the external heat. So in this case, delta U equal to Q when no work is done at the constant volume. Here what happened? At a constant value, whatever the changes are there, heat. Okay, here Q, that is equal to what? Delta U. Okay, here whatever the changes in the heat is there, Q, that is equal to what? Delta U. Now here also we have the sign convention. For the sign convention, here also you should be very careful with the sign convention. Okay, so internal here a sign convention of heat, if you see, when heat is transferred from the surrounding to system. Okay, means system is here, system is taking the energy, surrounding giving. Okay, so surrounding to system means system is taking the energy, means Q symbol is what? Positive. Okay, so when heat is transferred from the system to surrounding, means what? System is losing the energy, surrounding is taking the energy. Simply system is taking the energy means Q is positive, system is losing the energy means Q is negative. Okay, this sign convention is important. Next, third case what we have now. Next, third case, we are going to change the internal energy by heat and work together. Okay, first case we done with the only by work. Okay, next, second case we done with the change internal energy by what? Only heat. Next, in the third case, we are going to change the internal energy by heat and work together. Okay, at this case, okay, in this case, change in internal energy delta U equal to what? Here sum of the heat plus work. Okay, now this equation is a mathematical statement of the first law of thermodynamics. Okay, here already we discussed in thermodynamics we have the law. Now let us discuss what the first law of thermodynamics means. Exact definition I will discuss next. So if you see the mathematical expression, okay, what is the mathematical expression for the first law of thermodynamics? Means delta U equal to Q plus W. Okay, now what it will tell? Okay, The energy of an isolated system is constant. Okay. What is given there? The energy of an isolated system. Already we discussed in the types of system based on the boundaries. That is what? Closed system, open system, isolated system. So in the isolated system what happened? There is no exchange of matter and energy. So simple what it called here? The energy of an isolated system is constant. Okay. Now if you see the definition of first law of thermodynamics, what is there? First law of thermodynamics, it is commonly states as the law of conservation of energy. It is talking about the what? Law of conservation of energy. That is, energy can neither be created nor be destroyed. Okay. I mean whatever the energy is there, the energy going to convert into one form to other form, but it is not going to create, it is not going to destroy. For example, we burn the methane. Okay. Combustion of methane we done. Okay. So once for example, you better to take that apple fuel, okay, like cooking gas, okay. Methane, if you burn, what happen? Whatever the energy is there, it's going to convert into another form, okay. So energy, water, that energy neither going to create nor going to be destroyed. Simply mathematically, delta U equal to Q plus W. Here delta U is what? State function, but Q and W are path functions. Already we discussed path functions means depends on the path. Okay, they are independent on the state. So here state is here delta U is equal to state function, Q and W are path functions. Now here delta U equal Q plus W. What is the meaning of that one? For example, I have the delta V internal energy 50 joules. Then Q plus W should be equal to what? 50. So maybe in that case, if Q is equal to 0, W if work is 50 joules, then total how much? 50. Or another case, if internal energy 50 joules and W is 0, then total how much? 50 joules. Or if you take 25 joules of Q and 25 joules of W, total how much? 50 joules. Or you can take 60 minus 10, like whatever that may be, delta U equal to Q plus W, means sum of the Q plus W equal to what? Internal energy. Okay. Next, here we have a note. What is the note here? One important note. Thermodynamic properties, mechanical properties. What is the difference between these two means? Here thermodynamic properties here cannot find out absolute value, but we can measure the change. Okay, means we are going to measure the change in internal energy, means delta U we can find, but not we cannot find the only U. U means absolute value means what? You cannot find the U, but you can find the what? Change in internal energy means delta U. Whatever the thermodynamic properties are there, we are going to measure the change at the exact value. Now mechanical properties, if you see, we can find the absolute value. Example, here example for mechanical properties, volume, pressure, temperature, whatever that, we are going to find out the exact value. Okay, absolute value we can find out, but not here. Means here you can understand now what thermodynamic properties means. We are going to measure only change. Okay, that you have to remember. Now let us see the numerical problems. Now let us see the numericals. What is the given problem number 6.1? Okay, express the change in internal energy of a system when, okay, they're asking about change in internal energy when a system, okay, when first case is what? No heat is absorbed by the system from the surroundings, but work is done on the system. Okay, there is no heat absorbed means what? Q equal to 0, but what? Work is done on the system. On the system means what is sign convention we have to take? W positive. Okay, what type of wall does the system have? Means based on this, what type of what type of wall we have? Already we discussed, means nothing but boundary. Okay, so you have to tell, is it a adiabatic wall or is it a what? You can tell about the thermally conducting wall, like that you have to tell. Okay, now let us see the solution. Okay, first what they given, no heat is absorbed. Here data given what? Q is equal to 0. Why? Because means already told no heat is absorbed. Next what they told, work is done on the system. On the system means what is the W convention? W equal to what? Positive, how to take. According to first law of thermodynamics, what? We have the mathematical expression delta U equal to Q plus W. So if you substitute here, Q value is 0. W is what? Here you have to take the positive. So total if you see that delta U equal to what? W adiabatic. Okay, why we are calling as adiabatic here? Especially why is here mentioned adiabatic? Why? Because means there is no exchange of heat. How I came to know? Why? Because here Q is equal to 0. So Q is equal to 0 means the type of wall is what? It is a adiabatic wall. Okay, this is a adiabatic wall. Next, what is the given second one? No work is done on the system, but Q amount of heat is taken out from the system, okay, and given to the surrounding, means system is what? Losing the energy. What type of work does the system have? Here no work is done, means W is 0. But Q amount of heat is taken out, means what? System losing the energy. System is losing the energy means Q is what? Positive. Now what type of wall means? You can tell here what? Simply thermally conducting wall, means here there is a exchange of what? There is a exchange of heat, okay. Now if you see the sign convention here, so here no work is done, means W is equal to 0. Q amount of heat is taken out from the system, means system is losing the energy. So Q equal to what? Negative. So according to first law of thermodynamics, here what's the mathematical expression? We have delta U equal to Q plus W. Now here Q is what? Negative. Why? Because means system is losing the energy. Minus plus no work is done. So W is 0. So delta U equal to what? Minus Q. So there is a what? Transfer of Q is taking place. So it is called as what? Thermally conducting wall. Okay. Next, if you see the third one, what is the given? W amount of work is done by the system. Okay. Here we have the W amount of work is done by the system again, and Q amount of heat is supplied to the system. Okay. Heat also supplied. Some work also done by the system and Q amount of heat supply system. Now what's the question there? What type of system it would be? Now you have to again ask the what type of system is it there. Okay. Now if you see the solution, so here what is given? Work is done by the system. By the system means W what? Negative. Q amount of heat is supplied to the system, means now system is taking the energy. So what is symbol of Q? Q equal to what? Positive. Now according to first law of thermodynamics, what is the mathematical expression? We have delta equal to Q plus W. Now here if you substitute here, Q value is what? Positive, and W is what? Minus W. Here exchange of heat is taking place but not the matter. Therefore it is a what? Closed system. Here if you see there is a Q. Q is coming in out, okay. So but not the matter is not going. So this type of system is called as a what? Closed system, okay.